Our study is motivated by a commonly seen type of data, the survey data in the social science research. While this kind of data has been commonly shared around different research groups, they're usually considered with different kind of privacy risk exposure and also being regulated with the capacity that can be shared around. Studies have been using different anonymization and de-identification techniques for data protection, but they may sacrifice data quality and granularity at the same time. Acknowledging this kind of challenge, we use L2 national voter file, a large-scale dataset that includes all the registered voters and demographic information in the US in the 2020 data samples. Using different sampling procedures for national, California, and Texas with various sample size from 1,000 to 50K, we're able to systematically evaluate what's the capacity of different synthetic models in terms of generating the synthetic data for across different kind of variables. For the model selections, we consider both traditional non-parametric models from the synthpop to more commonly seen deep learning-based models such as CityGAN and TAVE to the newer LM-based approach, which is the real-time formers, compare it against our baseline, the SMOTE models. We include two general type of global metric, which is the general utility, also known as fidelity, that come with 5 different metrics and 4 different kind of privacy measures. Additionally, we consider the target-specific utilities, which assess the performance of different synthesis models in the downstream applications. And specifically in our context, we select the 3 dependent variables with different classification models. Visually assessing the distribution, we observed that all the models were able to approximate the real data distribution pretty well, with the larger data set for training tend to perform much better in terms of approximation. One thing that stands out remains the CityGAN's data-hungry capacities, which tend to fail to approximate the distribution when the data sample is very small. Looking at the global evaluation of general utilities, we observe that the synthpop tend to be the best candidate here. In terms of the privacy consideration, CityGAN performs better across all different measures. Considering target utilities, we recognize that real-time formers and TVAE both perform very well in the context. In conclusion, we observe that different models have the strength that perform well in different kind of evaluation metric, highlighting the need of considering a comprehensive dimension of the evaluation for synthetic data generation. Particularly, synthpop excel at the global utility, while TAVE excel at different classification and downstream applications, but can be compromised on the risk of data overfitting. Real-time formers tend to have a more balanced performance across both general and target-specific utilities. And finally, if privacy is more of the concern, CityGAN is recommended.